Hi kids, time to do some review. So this warm-up is a similar problem that you did on the quiz, where it is displacement, distance, and position. And I want to make sure to do another problem like it. And I think most of you, because the math isn't terrible, I just want to make sure that you get all the points that you can get from AP, because AP likes to phrase questions like this, and I want to make sure you write everything for full credit. So this would be on a non-calculator portion of the AP exam, and it asks you, or it gives you the velocity. You're expected to know that is the first derivative of position, and that it is an algebra 1 parabola that opens up. So you are expected to factor this velocity. And again, this is algebra 1, so hopefully it's not too bad. To get t is equal to -1/3, which is outside the interval that they gave us. So the velocity function in my head, I see this. I know that the y-intercept is at -1. I have a parabola that I don't care about this side, and that on the x-axis, I cross at 1. I don't know if it goes down at this point or just goes straight up. I don't know where the vertex is. I don't really care. I just care about where the velocity is negative and where the velocity is positive. Velocity negative, velocity positive, velocity changes sign from negative to positive at t equals 1. So no one asked me to draw a number line, but I'm going to. Endpoints are 0 and 10. The velocity is 0 when t equals 1. The velocity is negative before, positive after. Now this says given a velocity of the particle, oftentimes these particles are moving left and right. So I'm going to say, it didn't specify in this problem, but I know they often write these problems as particles moving along an axis, right? So even though I've graphed this on the v of t plane, I think to myself, a particle starting at time equals 0 goes left for 1 second, then turns around and goes right. Right? Left for 1 second, turns around, and goes right. That's the movement of my particle. The displacement just wants to know, relative to where I started, how many steps did I take? So I really just need to know those many steps. That comes from integrating velocity. I don't have to write the velocity function again. From 0 to 10. They didn't ask me to evaluate, just asked me to write an integral expression for displacement. Here, AP won't ask you to write both. It'll be one or the other, since this is a non-calculator part, or they often will say without, even if it's a calculator part, without absolute value, which is what we did on the quiz. Without absolute value, they want the total amount of steps taken. So you need to include the left steps and the right steps, right? All of the right steps. So distance, if I was allowed to use absolute value from 0 to 10, absolute value the velocity function. without absolute value, which is much more likely that AP will ask you to do because it tests two objectives at once, integral properties, as well as do you know what distance means. You need to negate the left to make them positive and add all the steps going to the right. But for position, look at what information we never used. At time equals 2, not on the velocity graph. If the velocity is squared, what is the position graph? It's cubic, right? So I have some kind of cubic function, and on my cubic function, at time equals 2, I'm already at a position of 5, right? Or if you want to think here with my left and right movement, at time equals 2 seconds, my position was already 5 steps. So, firstly, since t is equal to 2, since t is equal to 2, where am I moving? The velocity is positive, right? So I'm moving to the right. So I don't care about absolute value or negatizing anything because I'm only going to the right. From 2 to 10, but I didn't start at 0. This gets me displacement from 2. But that's not position because you have to add where you started. Whoops, I'm sorry, it said at time 4. So I don't need to go all the way to 10. So at time 2, I was already at position 5. Add how many steps I took, right? Or my displacement from 2 to 4. Now, that's not the only way to do this problem. And I saw many of you on the quiz actually do, because this wasn't hard to do, you actually found the position function, the cubic function. That's not hard to do, right? The actual position function is what? T cubed minus t squared minus t plus what? Plus c. But you can solve for c. So 4 minus 2 is 2, right? So your position equation was actually t cubed minus t squared minus t plus 3. So at time 0, what position were you at? Right? Where were you at 0? You were at 3, right? So another legitimate answer to this would have been 3. Plus the integral of what, though? Where did time start? This time, position of 3 started at time what? Yeah. And guess how many correct answers there are to this problem? Lots, as long as you included a position, displacement after starting position. Time 0, you were at 3, then add the displacement to 4. Time 2, you were at 5, add the displacement until 4. Okay? So so again, lots of ways to get the right answer, but one of the way I first did it eliminated the need to actually integrate, right? And because this problem never did ask me to integrate, it just asked me to set up a bunch of things. So I still could answer 3 without integrating. Would have saved me some time. All right, so now we're going to practice some exponential growth and decay and logistic problems. So this handout is linked on our Canvas page. So I have 2 dogs infected with a virus. Holds a maximum of 50 dogs. The virus spread among the animals, and 2 days later, 10 dogs were infected. Assuming the logistic growth model given to me, notice what I've highlighted. So I've highlighted that I have logistic growth, and I've highlighted that y's are on the wrong side of the equation, which means this is a separable differential equation. And they want me to solve for y. But remember, AP allows you to say, nah, I'm not going to solve for y. I'm not going to do separable differential equations. I know the solution to a logistic growth model is y is equal to m over 1 plus act. And my job is to fill in a, or find a, fill in m, and find k. That's my job. So I certainly can start with m. Second, I'm going to find a. If you looked at the video, I did give you a formula for a, or you can just plug and chug. To find a, you plug in t is equal to 0. And solve for a. Oh, I'm sorry, at time equals 0, how many dogs did I have? 2. So I'm going to cross multiply. 2 times this is equal to 50. And then I'm going to divide by 2, so I'm going to get 25. Is equal to 1 plus a. A is equal to 24. So y is equal to 50 over 1 plus 24 e to the negative kt. Right, and remember what a is. It's not your initial condition. It's how many more groups of your initial size, which is 2, can fit into your maximum carrying capacity. That shouldn't be a surprise that that is 24. Now let's go after k, and we go after k using our second point. So 10, and you would be using a calculator to do this. After 2 days, there were 10 dogs. Use your calculator, solve for that. I'm not going to model that. I am going to write down K, and I'll write down just 3 places past the decimal. But I stored this in my calculator because I'm going to use that. So my answer to A I found y as a function of t. That's my answer to A. Now my answer to B is going to use that model. If the spread of the virus is not halted, after how many days will 25 dogs be infected? You just have to decide where you're going to plug into your model, where you're going to plug 25 in. You're going to plug it in for T, or you're going to plug it in for Y. Hopefully you know to plug it in for Y. And I am not going to do math on this. I have a calculator in my hands. I'm allowed to find a point of intersection on my calculator. So I had already put this into Y1, but instead of 0.895, I put K. So I typed 1 plus 24e to the negative KT because I had stored all the decimals of my K into my calculator. And then I put 25 into Y2. I adjusted my window so it went high enough to get 25. I made my Y max like 50. And then I found the point of intersection and I just wrote down my answer. I'm solving for T. So I wrote T and I rounded to 3 places past the decimal. Usually often AP will say round to the nearest day or something like that, but this problem didn't. But make sure if they give you units, you give them units back. Here's my answer to B. So that was a practice of a logistic growth model. The next problem is not logistic. Can you tell? Look at the differential equation. The population grows at a proportional rate, where the rate of change of the population is equal to a constant times the population itself. That is a separable differential equation. If they want to find a model for the population, you have to solve for P. Because you don't have P, you have the rate of change of P. But remember, AP allows you to say, nah, not going to solve the differential equation. I know the model of an exponential growth rate, right? This is not my logistic. Exponential growth rate is the population P is equal to the initial population times e to the kt. Population grows, so k is positive. So I can already fill in. My job is to fill in the initial population and t. So the initial population ain't no big deal. That's right here. Unlike logistic, I don't have to solve for that multiplier because it is the initial condition. Then I just have to solve for t by using my second point in 1987. So how many years is that from when time started? 86 to 87 is time 1. divide by 4936, log, all that kind of stuff, and you'll get K, ln, I'm sorry. And again, I wrote down 3 places past the decimal. So I wrote my model. With 3 places past the decimal, but I stored this value since I'm going to use it in part B. Use the model to predict the population in 2012. So show your model. You have a calculator. You don't have to do the math, but you do have to show where you are plugging in the setup. So 2012, how many years is that after 1986? Right? That's a little simple math I can do, I think. But let's say you did that simple math wrong, right? If you show that you've plugged in the 26, right, your answer, you can get follow-through points. I did round this. Right, Google, right? Google, how close was this to, what was the population in 2012? Was it close to this? And would this model be good now? So this one was an exponential growth model. AP often says things like the bacteria was growing and doubled, right? So instead of solving for your K, you have to know that if your population's doubled, right, what K would be instead of actually solving. Or you just say, oh, my second point then, if it doubled in 3 years, my second point is 3 comma 2 times the population, right? That's something the initial population. And then you can solve that way. So sometimes with exponential ones, you have to generate your second point, because remember, I used my second point here. Sometimes you have to interpret that from the language. It isn't just stated as explicitly as it is here. All right, one more. This is another practice of logistic. Can you tell? Look at the differential equation. Now, notice in the first 2 problems that we practiced, I said assume, well, in the first one I said assume a logistic model. But I didn't say exponential in the second, but I gave you the differential equation. Also here, I didn't say logistic, but I gave you the differential equation. Can you tell? This is not exponential. That's the exponential part, but then you have your m minus p here, right? Only they said y. M minus y. Oh, by the way, I know m. Do you? One time when I visited Hawaii, we went to, where did we go? Oh, we went to the Dole manufacturing, the Dole farms where the Dole pineapples are grown. And they had a koi pond there, but they didn't control. The population was ridiculous. And that had reached its maximum carrying capacity. The pond was just undulating with these orange, what do they call them? Koi fish. These huge goldfish. It was actually kind of disgusting. It was disgusting. But it had reached its carrying capacity. So why is my population of fish after T days? So I've already answered A, right? A is 500. What is the maximum number of fish? Only it didn't say it in words. You had to interpret it from the equation. Write the solution. Notice this time they didn't say solve. That was kind of nice because that's the clue that you can say, nah, I know to find the equation for, Oh no, it did say write the solution, but it didn't say find the solution. The solution to the differential equation, in other words, get y by itself, would be undoing the derivative, which is an antiderivative, a separable differential equation. And remember, if you remember from the video, that takes partial fractions and all that and a whole bunch of algebra. It's kind of nasty. I would like to avoid it if I can. AP allows you to avoid it if you remember the formula. They don't give you the formula. The fish, the solution to the differential equation, getting y by itself, is y is equal to the carrying capacity over 1 plus, not the initial condition, right? Those groups of initial population. That's the model with my m of 500, but I have to solve for k. How can I solve for k? 50 fish, right, at the beginning. So at time 0, I had 50 fish. And I'm just going to set this up, right? I don't need to show a bunch of math here because I am using my calculator. Whoops, in for t, I put 0. So I am solving for a. Now what do I have to do? I gotta solve for that k. Can you see how to do that? No. No, I can't. Wait, what? Why? What the heck? Wait a second. I can see k in the differential equation, right? Right? Remember that? Aha! Remember, the logistic differential equation model is k over m times 500 minus m minus p over m. Whoops, sorry, my m is already over here. I already moved my m over there. So look at your differential equation. Hey, you've got m. You've got minus p. Oh, I keep saying y instead of, I'm writing p instead of y. Wait. Oh, gosh darn it. Keep forgetting. Sorry. Got ahead of myself. I've got the y. What is 0.003 equal to then? K over m, right? Right? So if k over m, oh, wait a second, what's my m? K over m must be equal to 0.003. So what's k then? Woot woot. Okay, that was the twist in this problem. The twist in this problem was realizing I didn't just have to remember my logistic solution. I was given my logistic differential equation, but I had to remember the information I got out of that. right? What I was given. And then I just solved for k. That was because I wasn't given a second point to solve for k. In the other problem, both of the other problems, even the one that was exponential, there was a second point to be able to solve for your k. I didn't have a second point, so I was like fumbling around. What do I do? What do I do? Oh, wait. I was actually given not just the logistic differential equation form, I was given the logistic differential equation flat out. And inside the logistic differential equation, not only do I see m, I see k as well. So now I am just going to answer the questions, right? I actually have my solution. Put my cloud around the wrong one. I've answered A and I've answered B. What is the y value of the point of inflection? Now remember, this is when we did this in the video, and I did this the long way. We used the first derivative, we found the second derivative, and we set it equal to 0, and we solved. We had to use implicit differentiation, and we solved for y. Now, if you have a calculator and you have the first derivative, you can put the first derivative in and find the maximum. You just have to remember that you can't enter y into your calculator. You have to put x, and when you look at the maximum and find the maximum of the first derivative, right, you have to realize that the calculator x value is actually your dependent y. Or you can do this algebraically and solve for, again, y. The y value of the point of inflection is either where the first derivative is at a maximum or where the second derivative is equal to 0 and changes sign. But AP allows you to skip this as well, as long as you remember that the y coordinate of poi on a logistic is what? Always, always maximum carrying capacity divided by 2. Our maximum carrying capacity was 500. So the y value is 250. Remember, a logistic solution is it what we call kind of like an S-curve, where it bounded above. Oh, geez. And that poi value, the y coordinate, is always half of the maximum capacity. So notice, so I found the answer to C. A, B, C. D is what is the population when the population is growing the fastest? That is another way to see, do you understand? That is your steepest slope. Your steepest slope will be at poi, so that is the x coordinate. 250 is the population. The x coordinate or the t coordinate is when that maximum population happens. So for that, I just need to go back to my original equation, which again, I have a calculator. I'm going to put 250 in for y, solve for t, do this on my calculator where the The solution is in Y1, 250 is in Y2, adjust your window. You have your, well, I didn't have to store because 1.5 was a really nice number. And when I was done, I got, oh, I didn't write it down. Sugar, I didn't write it down somewhere, sorry. So you can do this on your calculator. Find out when. Oops, I forgot to write that down. It's on the key though, I assume. All right. So found, oops, didn't write it. Find the number of fish in the pond after 1, 2, 3, 4, and 5 days. Well, that is just plugging and chugging again with your calculator. 1, 2, 3, 4, and 5. Don't do a bunch of work for that. For E, you just say y of 1, y of 2, and so on and so forth. I did write some of these down. Pay attention if they ask you to round. If they don't give you rounding rules, you always write 3 places past the decimal and units. I got 345 something. Gosh darn my pen. Blah, blah, blah. And 3, I got 451 something. And then I got 489 and 497. Notice that the growth over time slows, right? The jump from time 1, 166, to time 2 of 345 is a bigger jump than from 345 to 451. The jump between the population in time 2 and time 3 is bigger than the jump in population between time 3 and 4, 451 to only 489, right? Kind of crazy. All right. So that is our practice for some for exponential and logistic growth, which is on the test. And we are done, by the way, with our objectives. On the Unit 7 test, which will be at the end of next week, you will need to solve initial value problems. Distance, displacement, position, I just practiced that with you in a warm-up. Separable differential equations was on the quiz. Euler's method was on the quiz. Slope fields were not. You need to be able to sketch and interpret. And remember, interpret often means match. Solve in quotes exponential and logistic growth separable differential equations. Nah. Just memorize the form of the solution. That's why solve is in quotes, because you can solve them, but there are no rubric points for doing so. Oops, sorry, so remember, the formulas you need to know are your darn it. This was all on the quiz. And then again, I also just did a warm-up with you. Make sure most of you are good with distance versus displacement, but you struggled with the position. Make sure you highlight that. Solving separable differential equations. Remember, when I ask you to solve initial value problems, that's basically using an initial condition to find C. Doing the same for distance and displacement is just going from acceleration back to velocity, back to position, and then asking you for expressions oftentimes for distance versus displacement versus position. Solving separable differential equations, make sure you recognize separable. And it's when you have mixed equations, right? And you have the dependent variable on the wrong side. Sometimes I'll tell you separable, sometimes I won't. If it's separable and you don't recognize, you don't get any partial credit for that problem. So please, please make sure you look for that. I will ask you to do Euler's method if I want you to. And the mistakes I saw in the quiz with that was simply just not stopping. Either a simple mathematical, you multiplied wrong, or you didn't stop soon enough, right? You finished out that last row and wrote the last y value down instead of just after the second column. Then not on the quiz, again, was the sketching of a slope field and interpreting. Again, interpreting would just be matching. And then your exponential and logistic growth equations. So you do need to memorize. Exponential differential equation looks like this. And solution looks like this. Logistic and again, your test will be, the unit test will be on February 25th or 26th. Okay, so our next class. You also will have on Wednesday, you'll have an AP to do on Wednesday. $224, right? It will not be exponential or logistic growth, but it could involve some practice with separable and distance and displacement, possibly, right? Initial value problems could contain that, but I won't put exponential logistic growth and problems on there. Okay. All right. I will see you on March 1st. Oh my gosh, can't believe it's March 1st already. We're getting close. Bye-bye.